Hello and welcome to part 3 of lesson number 3 in Unit 2A Quadratic Functions, Forms, and Transformations in our grade 11 University College math class. This is Transformations Part 2, Translations of Functions. In the first two parts we learned what a horizontal and vertical translation look like, or where they appear in our parent function. As you can see here, horizontal translations occur within the bracket with the x. If it looks negative, it is actually a positive value based on the negative that we get in this equation when we're provided it. So that would be a horizontal translation to the right h units. If it looks like a positive value, it's actually two negatives banging up that we've crystallized down to a single sign, which is positive. So that is a horizontal translation h units to the left. Vertical translations are a little more straightforward in that what you see is what you get. The k value sitting there at the end, if it's a negative, it's going to be a horizontal translation or a vertical translation down, and if it's a positive value, it's going to be a vertical translation up, k units. We did a few graphs, we did a first example, and now we're going to work through the remaining examples. Let's start with number 2. So the graph of y equals x squared is translated 3 units to the left and 5 units upward. Write the equation of the transformed function and state its domain and range. All right, so let's start with just by rewriting our vertex form here. So y equals a x minus h all squared plus k. So we know that we have a horizontal translation. That's 3 units to the left. And we have a vertical translation 5 units up. 5 units up. So we're going to slot these things into the appropriate places. As we know, the horizontal translation shows up in here. Now we've been told that it is a horizontal translation 3 units to the left. So that means it's actually a negative 3. And if we were to substitute that in, we would end up with y equals a x minus 3 all squared. Oops, let's get a bracket there. All squared plus k. So that's actually going to be a y equals a x plus 3 all squared. And let's have a look at that k value. We know that the vertical translation is 5 units up. We take that one at face value. So that's going to be 5 units up or plus 5. So there you have the transformations made to the equation y equals a bracket x minus h all squared plus k. We've substituted those two translations in. This is what we ended up with. Now the a value hasn't been provided, so we would just probably leave it off, and we would just say therefore y equals a plus 3 all squared plus 5. We're going to bring it kind of all together, including the a value in the next lesson. So for now, if it doesn't say, we'll assume that a value is going to be 1. And let's state the domain and range. So the domain then will be equal to set of all x, such that x is an element of real numbers. This is a theoretical parabola, so there's no limits on the domain. The range, however, is modified by the vertex and the direction of opening. So in this case, what is our vertex going to be? Well, interestingly enough here, our vertex is going to be the h and k values. So the y component of our vertex is right here. That's going to be a 5. So we know that 5 represents either the highest or lowest point. Sorry, we get a y in there and then a 5. Either the highest or lowest point. We don't know which yet. Next is about the direction of opening. And as we recall, the a value out front tells us our direction of opening. Now we haven't written an a value down here. So if it's not been provided for us, we're going to assume that our a value is a positive 1. With a positive value, it means our parabola opens up, which means that our vertex will be the low point. So all of our y values applicable for this new transformed function will be greater than or equal to 5 with respect to the y values. So there you go. That's number 2. We've done some modifications to that, made some transformations, and written down the domain and range. Let's have a look at number 3. The unlabeled parabola is a translation of the function y equals x squared. Write the equation of the translated graph and state its domain and range. Okay. So here's our parent function. It's just kind of happening here. Then we have our new function over here. So where has it moved to? Well, horizontally, it's moved from 0 to 2, as you can see here. So that's going to be a horizontal translation 2 units to the right. And if we look at our vertical translation, it's gone from 0 up 1, 2, 3. Oops, sorry, up 1, 2, 3. So there we have 3. So we have a vertical translation 3 units up. So let's slot these into our parent function. We have y equals a x minus h all squared plus k. Now a horizontal translation, and again we're going to leave that a value as a 1. Our horizontal translation is to the right, which means that it's a positive value that we're going to be substituting in. So that's going to be x minus positive 2 all squared. And our vertical translation at face value is 3 units up, so that's going to be plus 3. Let's condense those two signs down to 1. And there we have it. Our vertex, of course, being 2, the opposite of how it appears in the bracket, and 3, exactly as it appears for k. So there it is, our newly created equation. Let's talk about the domain and range. So again, we can see it visually. Here's our, let's change up our color here a little bit. Here's our graph. We see that it opens up and has the same plot pattern as the parent function. Let's start with the domain. The domain, of course, will be wide open. The domain equals the set of all x, such that x is an element of real numbers, no limits. The range, as always, will be limited by our vertex, and specifically the y component of our vertex. So the y component of our vertex, as we found out when we considered what transformation moved us vertically, is going to be 3, and our parabola is going to be opening up. So we're going to be talking about all values greater than or equal to 3 for our domain and range. So that's example 3. Now example 4, the final one here, this is a little bit of sort of like detective work. So 2 points on the graph of the function f at x equals x minus h all squared plus k are 7, 4, and 1, 4. Plot these points on a coordinate grid. Describe how you might find the coordinates of the vertex. Okay, so for us here, again, we have 1, whoops, let's get a highlighter here. We have 1, 4, and we have 7, 4. So we have a couple of points. We want to know what the parabola, I think it's asking for describe how you might find the coordinates of the vertex. So what do we know about parabolas? Well, one thing we know about parabolas is that there's an axis of symmetry that runs down the middle of them. So halfway between these points would be our axis of symmetry. So I'm just dotting in an axis of symmetry here. And this is one way. There's a few different ways to go about figuring this out. But there we have x equals 1, 2, 3, 4. There's our halfway point. Now we know the vertex is on here somewhere. I think another key to figuring this thing out is looking at what our a value is. Now because it doesn't say, we've not been provided any different information, we're going to say that our a value is equal to 1, which means that our plot pattern, let me see here, our plot pattern, just looking for some space, it'll be 1, 4, 9. And again, remember, that's from our vertex out 1 in both directions, from our vertex out 2 in both directions, and from our vertex out 3 in both directions. Now again, I don't normally write that, but there you go. And we're going to multiply that by our a value, if we recall from lesson 2. It's going to dictate our plot pattern, and our plot pattern from the vertex and out 1, 2, 3 is going to be 1, 4, and 9. So what does that tell us? Well, it tells us that these points here, so here's our sort of axis of symmetry, 1, 2, 3 units out in either direction. It's going to take us, then these points will be 9 units up or down from our vertex. Now assuming that our parabola is going to open up with an a value of positive 1, 9 units down from here will be our vertex. So 1, 2, 3, 4, 5, 6, 7, 8, and here's 9. And let's sketch our plot pattern on to make sure that that works. So we go out 1 from the vertex in both directions and up 1, out 2 and up 1, 2, 3, 4, and then out 3 and up 1, 2, 3, and then up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And there are the points that we were provided with at the beginning. So let's just give a little quick sketch on here. I think it looks very much like a parabola, keeping it a bit curvy there at the bottom. There we go. Get some arrows on that. So this is one way that you can figure out what the vertex is, and there's lots of them, but this one here would then be at point 4, so a horizontal translation 4 units to the right, and then 5 units down. And this is one way, and I'm not going to write all of this out, but this is one way that you can go about finding the vertex. Another is to take all the values that you know. I guess we have some time. We might as well show it here. So if we consider that we have a known h value, and the h value is going to be the x component of our vertex, and we know that that's going to be equal to 4. We know that, again, without any other information, our a value is going to be equal to 1. and we actually have an x and a y value. Either of the points that we have already put on the graph will be relevant. Let's pick 1 and 4 because it's a little smaller. So if we were to take our empty function, x minus h all squared plus k, and we were to substitute in these values that we know, so the y value is going to be equal to 4, a value will be equal to 1, x value is equal to 1, h value is equal to 4, and what we don't know is going to be the k. We can work our way backwards to figure out the other component of the vertex. So let's do a little bit of math here. There's 4, keep that 1. 1 minus 4 is going to give us negative 3 squared plus k. Let's do a little more math here. 1 times negative, so negative 3 squared will give us 9. So that's going to be 9 plus k. And to isolate k, we are going to transpose 9 over to the other side by subtracting 9. That'll give us negative 5 is equal to k, which we found using sort of what I would call like the hack and slash method over there already. So these are two different methods for figuring out what the vertex is going to be. This, of course, then would be the vertex of 4, negative 5, which we already knew. This is an algebraic way to do it. There's also a graphical way to do it as well. I'm not picky about which way you do. You have to demonstrate some knowledge of parabolas either way, so I'm happy with that. That's the end of our lesson. You'll notice the starred questions from our homework are challenge questions, so if you're feeling up to it, by all means give them a go. If you have any questions about the homework, including the challenge questions, reach out right away, email, in person, or in our in-class video chat. Either way, we'll get it taken care of. So there you go. Good luck with the homework, and we'll see you in lesson number 4.